Hi everyone, hope everybody is doing well. Let's go ahead and do our experiment 4 pre-lab questions. Okay, so your question 1, a solution of a weak acid was tested with indicators used in lab experiment 4, which is your buffers and their properties. The colors observed are also listed below. Use this information and table 1 in the experiment 4 to estimate the pH of this solution. So you have two information that would be helpful for you to find out what would be the pH of the solution. So first let's look at the indicators. So indicators are organic molecules that they can change color based on the hydrogen ion concentration in the solution. So methyl violet is one kind of an indicator. In this solution, if you put a drop of methyl violet, it has become violet in color. In thymol blue, that's going to be yellow. In methyl orange, you put couple of drops of methyl yellow, that would give you an orange color. And Congo red, with Congo red indicator, solution will become violet, and bromocresol green, the solution will become yellow. Okay, now this information alone will not be helpful for you to find out what would be the pH of the solution. So we have to look up this experiment 4 table 1, which I have posted on your Blackboard site. When you open up the questions, you'll be able to click this experiment 4 table 1 and it will take you to your PDF. Why this guy is not moving up and down? Come on, come on. Okay, now it is. Let's go to experiment 4. If you open, so you can also see it here before you begin, but if you don't see it, attachment right here, you can click experiment 4 pre-lab, and then when you open it up, you will see experiment 4 table 1 PDF. You click that, it'll show you. So this is the table 25.1. Table 1 is what you are going to use to find out the pH of the solution. Now any indicator can give you a color change. So with methyl violet, give you a color change yellow to violet. It would be yellow if it is a pH 0. Let's say you put couple of drops of methyl violet in a solution, it gives you a yellow color. That would indicate the pH is going to be around 0. But the methyl violet give you a color as violet, then you know that the pH is going to be not 0, it's going to be 2. Similarly, thymol blue would be red in color if the pH of the solution is 1, whereas thymol blue will give you a color yellow if the pH is 3. So that's how you use this table to find out the pH. With methyl yellow, when you add a couple of drops of methyl yellow of a solution gives you a red color, that will tell you the pH is about 2. But it's not exact. We cannot say it's exactly 2. It could be 2.5, like that. It would be red if the pH is 2, but if the pH is yellow, it would be 4. Between red and yellow, remember the red color you all know, and the yellow is yellow, right? What can come between red and yellow? What would be a good color that you could see when the color changed from red to yellow? That would be orange, right? Maybe around pH 3. If it is orange in color, that would be pH 3. Similarly with Congo red, the solution would be violet in color if the pH is 3, whereas if the pH is 5, it would be orange red. Bromocresol green, it will give you a yellow color if the pH is 3, and then the blue would be pH of 6. And you will see some shadings of the colors if it falls in between. Okay, so this is the table that we are referring. Now let's look at our question. With methyl violet, it's violet in color. Thymol blue, yellow in color. Methyl violet, violet. So let's look at here. Methyl violet, violet in color. So what do you think should be the pH? Is it going to be 0 or 2? Close to 2, right? So that is, then we know it is not going to be pH 0 with methyl violet. It's going to be violet in color. And similarly, thymol blue, it's yellow in color. So thymol blue, yellow in color. What do you think about the pH? If the solution gives you a yellow color with thymol blue, then the pH is going to be 3, right? With methyl violet, it's violet, so it's around 2. And then with thymol blue, it's yellow, so then it gives us, definitely it's going to be between 2 and 3, right? Because it's yellow in color. Let's see the other ones. Methyl yellow, it's orange in color. Methyl yellow. Methyl yellow, red would be pH 2, yellow would be pH 4. It is orange in color. If it is orange in color, where do you think the pH lies? Between red and yellow, so that could be, the solution is pH 3, right? What's the next one? Congo red, violet, bromochrysol green, yellow. Congo red, violet. So let's look at Congo red, violet. So if the solution is violet in color with Congo red, what pH do you think that's going to be? pH 3. It's not orange red. If it is orange red, then it's going to be around 5. And with bromochrysol green, it's yellow in color. Now our question is, what is the pH of the solution? So what do you think? Is it going to be 2? Going to be 3, 4, 5, 6, 7? Which one it is? It's going to be, I would guess it's going to be 3, right? Because with methyl violet, it's violet in color. With thymol blue, it's yellow. With methyl yellow, it is orange in color with methyl yellow. If it is pH 2, then it would be red in color. Then we would say it's pH 2. Since it's orange in color with methyl yellow, then it's going to be pH 3. And with the Congo red, it's violet. Bromochrysol green is also yellow. So we could safely say that the pH of the solution is 3. Okay. So similarly, now I did the first question with you. I believe it's going to be pH 3. And similarly, you can do the second one. Same thing, solution of a weak acid was tested with the indicators used in the experiment 4, buffers and their properties, and the table 1 is also given here, which is the same table. With that information and also the colors that is given, you can find out what is the pH of the solution. So I'm going to leave it for you guys to figure that out. Question 3. The pH of a 0.1 molar solution of hydrogen cyanide is 5.2. What is the hydronium ion concentration in this solution? The chemical equation for the dissociation of hydrogen cyanide in what is given below. So it is given in your pre-lab assignment. So this is the equation. Hydrogen cyanide with water, HCN, is it acid or a base? Hydrogen cyanide. It is an acid, right? Acid with water acting as the base is going to form hydronium ion H3O plus and conjugate base of cyanide. So it's a weak acid. Are weak acids going to 100% dissociate in water? No. Weak acids, they are weak, so they would not 100% dissociate to give ions. So that's why we write the equilibrium arrow. Okay. So the pH is given as 0.1 molar. We want to find out the hydronium ion concentration. This one. Normally, what is pH? pH is the representation of hydronium ions, how acidic is our solution is. And we know pH equals negative log of H3O plus. So we are given the pH as 5.200. So if you want to find out the hydronium ion concentration, you would use anti-log button and then use negative 5.200, H3O plus, 10 base negative 5.200. Okay, and when you do put this information into your calculator, you will get a number something like this. Check to see if this number is correct. Okay, I may be doing some wrong calculations, but you guys need to check me out. 6.31 into 10 to the negative 6. And how many significant figures? Include 3 significant figures. So 6.31. Okay, that's the hydronium ion concentration. Again, check to see if you know how to perform these log and anti-log in calculator, and also if I did my calculations correct. And then the next one, what is the cyanide ion concentration in the solution described in question 3? So we found the hydronium ion concentration. We want to find out cyanide concentration. So let's say you started with 1 molar solution of hydrogen cyanide. So initially we don't have anything, 0, 0. Let's say X amount is being reacted. So then we're going to be making X amount of hydronium ions and cyanide ions because they are 1-to-1 ratio. So since we know the amount of hydronium ion, so then your cyanide concentration also going to be same as 6.31 into 10 to the negative 6. Also make sure when you write down your answer in the blackboard, you put it in the proper format, 6.31, and without any spaces you put E negative 6. So it's going to be the same amount. Okay, that's question number 4. Use the initial concentration of HCN 0.1 molar and your answers to question 3 and 4 to calculate the value of pKa for HCN. Express your answer to 2 decimal places. So we want to find out the pKa. So I have shown you here. Let me go ahead and write down this equation again. HCN with water giving you hydronium ion concentration and cyanide ions. Okay, so hydrogen cyanide concentration is given to us as 0.1 molar. 0.1 molar. At the beginning we have hydrogen cyanide, nothing has been formed yet. Let's say X amount is going to react, so then X amount going to form, and then so this is the initial change. So at the end, equilibrium I stable, you will have hydrogen cyanide 0.1 minus X, X amount, right? So how do you find out the pKa? We want to find out the pKa. pKa can be found out if you know the Ka. With the information that we know so far, we can find out the Ka of the solution. What is the expression for the Ka? So Ka, which is the acid dissociation constant, can be found out if you know the hydronium ion concentration, if you know the X, and 0.1 minus X. Hydronium ion concentration, cyanide ion concentration, and you divide it by hydrogen cyanide, HCN. We do not consider water because we use a lot of water. Water concentration can be considered as constant since we use abundantly. Now, what is our hydronium ion concentration? X, cyanide X, and HCN 0.1 minus X. And here we are doing an assumption, since X is very small, 0.1 minus X is going to be similar to 0.1. X is very small, so we're going to go ahead and do that assumption. And 0.1 is the concentration of HCN. Do we know the values of X, which is the hydronium and cyanide concentrations? Yes, we know. So that's why what we found in question number 3 and 4, which is 6.31 into e to the negative 6. So now basically we're going to plug in those numbers to find out the Ka. So the Ka therefore would be 6.31 into 10 to the negative 6. That's the hydronium ion concentration, and which is the same for the cyanide. So you can basically raise this power to the 2, since both of them are the same amount. X squared, which is this thing I just wrote, and HCN is going to be 0.1. This will give you Ka. Okay, so once you find out Ka, so 6.31 into 10 to the negative 6, you have to do that raised to the power 2, or 2 times you multiply, and that would be something like 3.98 into 10 to the negative 10. Excuse me, we are not done yet. So this is the Ka. What do we need? We need pKa. So how do we find the pKa? pKa equals negative log of Ka. So we found Ka. So you need to get the log of 3.98 into 10 to the negative 10. And then you multiply it by the negative at the beginning. So that will give you the pKa of the solution. pKa of hydrogen cyanide. So I'm going to leave it for you guys to find out the pKa. Okay, and express your answer in two significant figures. Okay, so get the log. What you need to do is this is what you need to do. pKa equals negative log of 3.98 into 10 to the negative 10. Okay, so that's how you find pKa. Okay, and then let's